Hi, here's a quick video going over the answers to the notes for Unit 3 from slides 1 through 15. All right, so this one is slide 6. So for slide 6 here, we are using the information. We know L, line M, and N here are parallel. L is the transversal. And we are given the first angle is 64 degrees. So angle 1 here, 64 degrees. 2, you can see, is a linear pair to 1. So 2 is going to be 180 minus 64, or 116 degrees. Angle 3 is a vertical angle. So it's a vertical angle to 1. Remember, vertical across the lines. So 3 is 64. 4 is a linear pair, either to angle 1 or angle 3. You could also say that it is vertical to angle 2. So vertical angle would work there as well, but 116 degrees. Angle 5, you can see angle 1 and 5 are corresponding angles, so they're congruent. That makes this 64. 6 is a corresponding angle to 2. 6 and 2 are corresponding, same relative position. So it's 116. 7. You could say 7 and 1 are alternate exterior angles. Alternate because they're on opposite sides of the transversal. And exterior, they're on the outside of the parallel lines. So alternate exterior, 7 is 64. And 8, if I compare that to 1, 1 and 8 are same side exterior, which means they are supplementary. So it is 116. All right. Let me get rid of my marks there. All right. So we had to use those angle relationships to help us solve problems here on slide 7. Notice slide 7. These two angles are same side interior. Same side interior. They're on the same side of the transversal. They're to the right of it. And they are inside the parallel lines. Same side interior angles are supplementary. So notice we added them together to be 180 degrees. And then solve that equation. 20 plus 19x is 39x. Minus 15 equals 180. Continue solving that and you end up with x equals 5. All right, the one to the right, again, if we are solving for x, these two, notice they are on the same side. And they are on the outside of the parallel lines. So these are same side exterior. Again, supplementary. So we added them together and made them equal to 180 degrees. All right, let's look at these on the bottom here. These two angles, the 6x and 10x minus 32, those are corresponding angles. They're in the same relative position. So they are corresponding. They're both just below the parallel lines. So that means they are equal to each other. So we set them equal to each other and found that x equals 8. All right, let's look at this last one here. We've got this angle and this angle. Notice they are on alternate sides. So alternate, because they're opposite sides, alternate sides of the transversal. And they're on the outside of the parallel lines. So alternate exterior angles are congruent. So you can see we set them equal to each other. And then solve that problem. Again, if you need to pause the recording, you can review these. Let me know if you have any other problems. All right, let's talk about another one here. Slide 8. Are these lines parallel? Notice 112 here. That means the linear pair would be 68. 68 and 68 are corresponding angles. So yes, since they are the same measure, those lines are parallel. The next one, those are vertical angles. Doesn't matter whether or not they're parallel. Vertical angles are always congruent. So this was the not enough information. The third one here, if I look at the linear pair of 80, it would be 100 degrees, and 180 are not congruent, and they would be corresponding angles. So since they are not congruent, these are not parallel. And finally, the last one, these pair that are 94 degrees are alternate interior angles. They are on alternate sides of the transversal. Interior, they are inside the parallel lines. Since they are congruent, those lines are parallel. All right, slide 9 gives you a little bit more information about the converse theorems. Again, ways to prove that lines are parallel. Slide 10, you had to complete the statements. So remember, we always start with given information. So A is parallel to B. That is given. The second part there is another given then. All right. So if A is parallel to B, then angle 1 and 8 are alternate exterior angles. They are congruent since this is parallel. Again, C and D, we are given. Angle 8 and 16, corresponding angles. And since 1 is congruent to 8 and 8 is congruent to 16, the transitive property says since 1 and 16 are congruent to the same angle, they must be congruent to themselves or to each other. All right. The second proof here, we have that the measure of angle 1 is 53. Measure of angle 2 is 127. That is our given information. 2 and 3 are right next to each other, form a straight line. They are linear pairs. I can substitute in 127 for angle 2. So the measure of angle 3 plus 127 is 180. The measure of angle 3, if I do some subtracting, is 53. And then we notice 1 was 53, 3 is 53. So therefore they're congruent. That is the definition of congruent angles. And since 1 and 3 are corresponding angles, and we said they're congruent, then the lines must be parallel. All right, then we moved on to triangle sum theorem. Remember, triangle sum theorem states that the 3 interior angles of a triangle must always equal 180 degrees. So if we look at this one over here, we need to find x. If we notice, these two are linear pairs. So this is 100. That means this must be 80. So 80 plus 51 plus 2x plus 3 must add together to be 180. 80 plus 100 plus 51 is, I think, 131 plus 3 plus 2x must equal 180. And we continue solving that. We end up with x equaling 46. All right, and again, to find the missing angles, we know this is 90 degrees. That means 3 is 90, 4 is 90. 3 and that 90 are linear pairs. 4 and the 90 are vertical. 2 is vertical from 68, so 2 must also be 68. 68 and 1 have to be linear pairs. So 180 minus 68, 112. For the interior angles, 90 plus 68, it's 158. So if we take 180 minus that 158, should be 22. So 5 is 22. 6 here is linear to 5. So they have to add together to be 180. 180 minus 22, 158. All right, and again, feel free to pause if you need to look these over. All right. 12. Again, using the triangle sum theorem. We had to state each reason. We are given ABC in the triangle on the left. Notice we also have the marks here. These marks say that they are parallel. That's what that arrow is, so that is given information. AC is parallel to BD. 1 and 4, those are alternate interior angles, and they are congruent since we said the lines are parallel. 5 and 3 are also alternate interior angles, so they must be congruent. If we add together 1, 2, and 3, has to equal 180 because that is the triangle sum theorem. And you'll notice I said 1 is equal to 4, so I can replace that here. 2, I said 3 is equal to 5. So that could be angle addition postulate or even substitution. Either one would have been correct for that one, but notice how I'm replacing those because I know they are equal. Since I said both of these equal 180, I can set them equal to each other. That's transitive property. And if I get rid of that angle 2, subtract it from both sides, that's the subtraction property of equality, and that's also what I was trying to prove. All right, and again, feel free to pause this if you need to. All right. 13 gave you some information about the isosceles triangle theorems. Remember that if the sides are congruent, then the opposite angles must also be congruent. The converse applies. If you know the angles are congruent, two angles are congruent, then the opposite sides must be congruent, proving it's an isosceles triangle. Remember, we do call the angles at the bottom the base angles. The one at the top, the vertex angle, and the legs are the ones we say are congruent. Also, a quick reminder, if one angle of a triangle is a right angle, then the other two angles must be complementary, which means adding together to be 90 degrees. Again, kind of using that fact that all three have to add together to be 180. All right. So the next one here, this was slide 14. This is using the isosceles theorem to help us here. So if NJ is congruent to NM, so that's making one big isosceles triangle here, then angle NJM, this angle, must be congruent to NMJ. That one. Again, that's the isosceles triangle theorem. If we look at this one, if LM, that one, is congruent to LN, so you can see creating an isosceles triangle here. That means that angle LMN, this angle again, must be congruent to LNM. That one. All right. If angle NKM, so this angle is congruent to NMK, this angle, so these green ones, that means the opposite sides must be congruent. NK must be congruent to NM. All right. And finally, LJN, this angle, is congruent to LNJ. This angle, it's congruent, it's creating an isosceles triangle here. Then LN must be congruent to NJ. Right. LJN, LNJ. think I had this one backwards, and I apologize. This should be LJ. Should be this side here. Those are the opposite sides. So I apologize on that one. I had a typo. That should be LJ. All right. Again, feel free to pause this for a moment if you need to. All right. Let's look at the next one. Slide 15, last one. All right. So we have our proof here. And again, we put the information that we're given. We list that as the first statement. Whoops, went too fast. So EBC, that's a given. AE is equal to DE, again given from the information here. And if we look at that, EBC, ECB, those angles, that means that EB has to be equal to EC. That's the isosceles theorem. Those opposite sides must be congruent. If I look at AEB, must be congruent to DEC. That's these angles right here. Those are vertical angles. So the triangle ABE must be congruent to DCE by angle, side, angle. And finally, AB must be congruent to DC by our old friend CP, If we know the triangles are congruent, which we proved in part 5, then the corresponding parts must be congruent. That's part 6. All right. Hope that helps for you guys. Let me know if you run into any problems.